Hello dear students, we are going to discuss dimensional analysis complete topic today. Right, now what is dimensional analysis? Before that we are having fundamental physical quantities as well as derived physical quantities, and representation of derived physical quantities in terms of fundamental quantities. We need to have a power representation over the fundamental physical quantities. With an example, I will explain you here clearly, and the thing what I discussed now, I am writing here as theory, and later I will explain you with an example. Now, dimensions. What is dimensions in physics? That is when a derived quantity is expressed in terms of fundamental quantities, it is written as a product of different powers of the fundamental quantities, and here the powers to which fundamental quantities must be raised in order to express the given physical quantity are called its dimensions. And see here, let us see with an example. See here, force is equals to mass into acceleration, and here mass is fundamental physical quantity and acceleration is derived physical quantity. So I can write it as mass into velocity by time, and here again velocity is derived physical quantity, so again I can write mass into displacement by time square. So here mass, displacement means length, and time, these are the fundamental physical quantities. So I can say mass into length into time minus 2. I am bringing it to numerator. Then here dimensionally we can represent it as dimensional representation is we have to represent in terms in the brackets, and answer should be with the MLT, and mass is 1, length is 1, T is minus 2. This is the dimensional representation of force, and this is called dimensional formula for the force, right? Then next one, similarly, if I am going to giving you two more examples. Number 2, let it be number 1. Number 2, density means mass per unit volume. So mass by length cube. So we can write it as ml minus 3, and here dimensionally we need to represent dimensional representation is, or dimensional formula is, again we have to write in bracket in terms of m, l, t. So m is 1, l is minus 3, t is, we do not have any t term, so it should be equals to 0. So we have to represent in the brackets first point, and we have to represent three quantities: mass, length, time, definitely. And third example is linear momentum. Linear momentum. Linear momentum means mass into velocity. Mass into velocity. So mass into displacement by time. So again mass into length into time minus 1. So dimensional formula of linear momentum is, dimensional formula is m, l, t 1, 1. So m, l, t minus 1, and this is how I need to represent in terms of dimensional formula. This is the way of writing dimensional analysis, and these are the things we are looking for translatory physical quantities. Now let us see for some angular quantities, how to write for angular quantities. Then dimensions of angular quantities. See here, first one is angular displacement. Angular displacement. What is angular displacement? Suppose if an object is moving from here to here, now this is arc length, and this is radius, this is theta. So arc length is equals to radius into angle. This angle is equals to angular displacement, which is equals to arc by radius. And here arc is having units as angular displacement, right? And here arc is having units in terms of meters, because object is moving from here to here, path followed like this. So in terms of meters we have to represent, and radius is also in terms of meters. So these two will get cancelled, obviously we will get 1. So dimensional formula becomes, dimensional formula is equals to m, l, t naught. So it does not has any dimensional formula. Then similarly, number 2, angular velocity. What is angular velocity? That is angular displacement by time. Angular displacement by time. And angular displacement is m naught, l naught, t naught, and time is m naught, l naught, t. So this is equals to m naught, l naught, t minus 1. This is dimensional formula for angular velocity. Angular velocity. And third one is angular acceleration. Angular acceleration. Angular acceleration means angular velocity by time. So angular velocity dimensional formula is m0, l0, t minus 1, and time is m0, l0, t. So which is equals to m0, l0, t minus 2. This is angular acceleration dimensional formula. Angular acceleration dimensional formula. Then next one is torque. What is torque? Torque is equals to force into level arm. Force into level arm. Level arm in terms of meters, Force means MLT minus 2, and it is in terms of meter means like this, and dimensionally we can say M2LT minus, oh sorry, in terms of meters means this is length, then this becomes ML2T minus 2. This is meters. So level R more, that is length is in terms of meters. So meters means dimensional formula is L. So obviously we can write it as ML2T minus 2, right? And next part is applications of dimensional analysis. Applications of dimensional analysis. Applications of dimensional analysis. See here, the first one is to convert a physical quantity from one system to the other, from one system to the other. See here, suppose as we are discussing, we can represent, this was we covered in our previous class, this is 2 meters or 200 centimeters. So we represented it as N1 U1 N2 U2 like 2 meters or 200 centimeters, right? And here this dimensional formula helps us to find the magnitude of one system of units with respect to, or by using other system of units, by using this one, and we will see that with an example. Now let us see. Before that, let me write the theory for this one. If a physical quantity X has dimensional formula MALBTC, and if the derived units of that physical quantity in two systems are M1A L1B T1C and M2A L2B T2C, like this, and here and N1 and N2 be the numerical values in the two systems respectively. Then N1 U1 is equals to N2 U2. So how can we represent this one? N1 M1A L1B T1C, N2 is equals to M2A L2B T2C. Therefore the magnitude which we are going to find is equals to N1 of M1 by M2 A L1 by L2 B T1 by T2 C. This is the procedure of finding magnitude of the physical quantity with respect to other physical quantity. This I will give you with an example for your clarity. And here convert Newton, 1 Newton into dyne, 1 Newton into dyne, and see here solution. The Newton is the SI unit of force and has dimensional formula m1 L1 T minus 2, that is A is equals to 1, B is equals to 1, C is equals to minus 2. Now in terms of SI units, so ultimately we can write 1 Newton is equals to 1 kg meter per second square, and here we can write the relation between SI units or SI system or CGS units in terms of, then M1 is 1 kg and M2 is 1 gram. So mass in terms of CGS units we can write grams, and in SI units mass is kg, and length is 1 meter, L2 is 1 centimeter, T1 is 1 second, T2 is 1 second. Clear? Now we are going to substitute in this formula, that is N2 is equals to N1 of M1 by M2 A, L1 by L2 B, T1 by T2 C. Then N1 value is they given as 1 Newton into kg in terms of kg, and M2 is, I am substituting the values which are in table, and meter, centimeter, 1 second minus 2, and these 1 minus 2 values we are getting from here, right? So 1 kg meter per second square, kg is having 1, meter is having 1, this is 1 kg meter s minus 2, that is 1 kg means mass 1, length 1, t minus 2. This is what here I am substituting, 1 minus 2, and this is equals to 1 10 to the power of 3 gram, 10 to the power of 2 centimeter, second by second minus 2, and which is equals to 10 to the power of 5, because gram will get cancelled, this will get cancelled, and this is equals to 10 to the power of 5, N2 value is 10 to the power of 5, therefore 1 Newton is equals to 10 to the power of 5 dyne, 10 to the power of 5 dyne, right? And this is how we can use N1 and N2 simultaneously. Finding N2 value by using N1. And next one is, and the next model of the question I am discussing for the same concept, and here we are actually trying to represent every model of the problems. I am trying my able best, and if still I left anything, please let me know. I will definitely make you to be clear. Magnitude of the force is 100 dyne in another system where the fundamental physical quantities are kilogram, meter and minute. Find the magnitude of the force. See, here they are representing first of all in terms of CGS units, and here they are not asking either of the SI units or MKS units or any other units. They are representing their own physical units, and we need to represent the given value 100 dynes in terms of these units. So first of all, by using the formula N1 M1A L1B T1C is equals to M2 A, L to B, T to C. This is the original formula, and we need to find N2 value M1 by M2, A, L1 by L2, B, T1 by T2, C. And here dyne is equals to, as we have seen, dyne is equals to gram centimeter second minus 2, gram centimeter second minus 2, right? Then that is gram means mass, centimeter means length, second means s, 1 1 minus 2, 1 1 minus 2. So A value is equals to 1, B value is equals to 1, C value is equals to minus 2. So here N2 and given N1 is 100 and M1 value is, dyne means gram by M2 they are giving us kilogram, kg power 1, and L1 value is, dyne means centimeter, and L2 value is meter, they are representing in meter, and time is in seconds for CGS system. These three represents CGS system of units, and here they are representing it is minute, minus 2. Now which is equals to 100 1 by 10 to the power of 3 gram centimeter 10 to the power of 2 centimeter second 60 second minus 2. Now 100 10 to the power of 5 into 1 by 60 minus 2, which is equals to 60 square. Because it is in the denominator, I am taking it into numerator, so it will be minus 2 will be plus 2 by, here after getting cancelled it is 10 to the power of 3, that is 3600 by 1000, which is equals to 3.6. So N2 value is 3.6. This is what they are asking us to find. Clear? Then next we are going to find next model of the question for the same concept. See here. Suppose a calorie is a unit of heat or energy, and it equals about 4.2 joule, where 1 joule equal to 1 kg meter square s minus 2. Suppose we employ a system of units, in which the unit of mass equals alpha kg, the unit of length equals beta meter, the unit of time is gamma second. Show that a calorie has a magnitude 4.2, alpha minus 1, beta minus 1, gamma 2 in terms of the new unit. We need to show this answer, and see here 1 calorie is equals to, 1 juice is equals to 1 kg meter square s minus 2. So here we can say kg m1, meter means L2, time S3. So A is equals to 1, B is equals to 2, C is equals to minus 2. First point. And second point is, and first SI system, Joule is the SI system unit. And next they are asking us to find in their way of units, that is new system. And here M1 we can say in terms of kg, 1 kg, and L1 we can say SI system of units 1 meter. T1 is equals to 1 second, and N1 is equals to 4.2 joules they are asking. So 4.2. Now M2 is they are giving as alpha kg, and L2 as beta meter, T2 as gamma second. So N2 is how much? This is what they are asking. Now by using N2 is equals to M1 by M2 A, L1 L2 B, T1 T2 C. So I am substituting 4.2 1 by alpha 1 and 1 by beta. Actually it is in meters, so meter will get cancelled. Sorry, 4.2 kg masses, and this is alpha kg 1 meter, beta meter, B values 2, here we got it as 2, 1 second, gamma second minus 2. So this becomes 4.2 alpha minus 1, beta minus 2, gamma minus 2. This is what is N2 value. This is what they are asking us to find. And next one is, next application of dimensional analysis is, right, to check the dimensional correctness of a physical relation. To check the dimensional correctness of a given physical relation. Right, see here, before we are going to solve some numericals, I would like to give you as a concept. Suppose we have a relation x is equals to a plus or minus bc whole square, or a plus bc minus under root of def, like this. Suppose we have a relation, then if we need to find whether the relation is dimensionally correct or not, we have to show, or we have to find dimensions of x is equals to dimensions of a, and dimensions of bc square is equals to dimensions of def. So individually the dimensions of each term in between plus and minus or plus, whatever that might be, has to be satisfied. So if it is satisfying dimensionally correct, therefore if it is satisfying, we can say the given relation is dimensionally correct, okay. But physically may or may not correct. Clear? And we will see what is dimensionally correct, what is physically correct with the examples. And let us see first example. Let us check v is equals to u plus EAT is dimensionally correct or not. So v is equals to u is equals to AT. This has to satisfy. And what is v? LT minus 1. Velocity is equals to LT minus 1. And u is also equals to LT minus 1. Acceleration is LT minus 2. T is T. So this is LT minus 1, LT minus 1, LT minus 1. Therefore, the relation is is dimensionally correct. And here we do not have any mathematical terms like 1 by 2, 0.2, 0.3, like any constant. Here we do not have any constant in this relation, so it is physically also correct. Therefore the relation is physically correct. So it is dimensionally correct as well as physically correct. And let us see with the next example, that is v square minus u square is equals to 2as. Now v square dimensionally it has to follow dimensionally v square should be equals to u square should be equals to 2as. So this is lt minus 1 2 lt minus 1 2 lt minus 2 and s is displacement, that is L. So this is equals to L2 t minus 2 L2 t minus 2 L2 t minus 2, but here 2 is present. That 2 we are not representing anywhere here. Therefore this says that the above relation is dimensionally correct, but physically not correct, because it is not giving any information about the term 2. Similarly, I am giving you one thing as homework. Find s is equals to ut plus half at square is dimensionally or physically correct or not. You can message me in our messages box, YouTube messages box. You can message me this answer, right? Then next one is next model of, and we will see some models of the questions over this concept. That is, let us say find out the unit and dimensions of the constants a and b in the van der Waals equation p plus a by v square v minus b is equals to RT, where P is pressure, V is volume, R is gas constant, and T is temperature. Right? Then here the terms which are in the bracket, they have dimensionally they does not have any dimensional formula. So V minus P is equals to m naught L naught T naught. So here V is equals to B. Now I can say B is equals to L3, because volume is L cube. So length in terms of 3 dimensional. Now dimensionally B is dimensional formula of B is equals to m0 L3 T0, m0 L3 T0. Now similarly here, and we found the dimensional formula of B. Now this is having no dimensions. Similarly P plus A by V square is equals to m naught L naught T naught. So we can say P is equals to A by V square, and here you no need to write neglect negative sign. It is the condition, neglect negative sign. So A is equals to P V square. And what is pressure? Pressure is equals to force per unit area, and this is volume square. So force means mlt minus 2, area means L square, and volume means L3 whole square. So this is equals to ml minus 1 t minus 2 L6, and this is equals to ml5 t minus 2. This is the dimensional formula for this is dimensional formula for A. This is dimensional formula for A. Now next application of dimensional analysis is dimensional analysis. Dimensional analysis helps us as a research tool to derive new relations. Right? Now see here. I will give you with an example. Finding time period of a simple pendulum. Time period of a simple pendulum, and here the condition is given condition time period t is directly proportional to length, and time period is inversely proportional to acceleration due to gravity. So here therefore these are the conditions. Now the solution is t is directly proportional to length by g, length and g, and here t is equals to, I can say, L by g. And next one, right, next one is we can write primitively t is equals to k m to the power of x L to the power of y t to the power of z. First of all, we need to write like this, and here t dimensionally I am representing k m to the power of x L to the power of 5, and okay beta, chalo, t is equals to k and L right, we need to represent with the mass also. So k mass is x, L y g z. Actually this is correct, sorry for the inconvenience. And the thing is here they are giving actually, let me discuss again from the first point. Here there is a small confusion actually. The given condition is time period depends on length and acceleration due to gravity. Acceleration due to gravity, that is t is directly proportional to length and acceleration due to gravity. Here I am representing this as x and y. Now t is equals to k l to the power of x g to the power of y, and t dimensional formula time period time seconds in terms of t, k length is l x, and acceleration due to gravity is lt minus 2 y. Now t is having 1, then k l x plus y t minus 2y. I hope it is clear now. Now I am comparing both sides. Comparing both sides. Then x plus y, it does not have any L term here, so we can say L is 0 and M is also 0. Of course here is also no M, right? Then x plus y is equals to 0, and and comparing t, this is by comparing L. Now compare t, so 1 is equals to minus 2y, then y is equals to minus 1 by 2, and here by substituting in it x is equals to 1 by 2, and substitute x comma y values in equation 1. That is, let us say this is equation number 1, right? Then t is directly proportional to L to the power of 1 by 2 g to the power of minus 1 by 2. So t is equals to k under root of L by g. This is the correct representation. Sorry for the previous problem mistake, sorry, previous explanation. And here this is correct answer. And physically the constant value is k is equals to 2 pi. So time period of the pendulum becomes 2 pi under root of L by g. But the drawback is here dimensional analysis does not help us to find k value. So this is the main drawback of using dimensional analysis. And the next one is we will see one more model of the question for your clarity. That is, for a particle to move in a circular orbit, uniformly, centripetal force is required, which in fact depends upon mass, velocity, radius of the circle. Express centripetal force in terms of these quantities. And see here, given that force is directly proportional to mass, velocity, radius, so I am considering them A, B, C as the values which we are going to find. Now F is equals to m l t minus 2. So forget about the constant, otherwise you can keep constant. And m is the mass A, velocity is lt minus 1 b, and radius means again length c. So this is equals to m a l b plus c t minus b. This is equals to m l t minus 2, right? Chalo, by comparing A is equals to 1, by comparing mass, A is equals to 1, again by comparing L, that is B plus C is equals to 1, by comparing length, B plus C is equals to 1, again by comparing T, b is equals to 2 by comparing time minus b minus 2 here, minus 2 and minus b is here, so minus b is equals to minus 2, b is equals to 2. Therefore by using b plus c is equals to 1, this relation, by using this relation we can say 2 plus c is equals to 1, c is equals to minus 1, c is equals to minus 1, a is equals to 1, b is equals to 2. Therefore by substituting a, b, c values in equation 1, that is, let us assume this is equation 1, f is equals or directly proportional to m to the power of a 1 and next b to the power of b, so b to the power of 2 and c to the power of minus 1, so c to the power of minus 1. So f is equals to k mv square, no, this is r, actually this is r, mv square by r. This is the relation between force and mass, velocity and radius. Now next model question from the same concept. If velocity v, force f, time t are chosen as fundamental quantities, express a mass and b energy in terms of vft. Okay, now question A, mass is directly proportional to velocity a, force b, time c. Okay, that means m is equals to lt minus 1 a, mlt minus 2 b, t, c. Otherwise I can write it as m is 1 m b l a plus b t minus 2b plus c. Now therefore by comparing mass, m is equals to, that is b is equals to 1 and a plus b is equals to, actually here l is 0, t is 0, so a plus b is equals to 0 and therefore a is equals to minus b or a is equals to minus 1. And next one is here by comparing length, by comparing time, 0 is equals to minus a minus 2b plus c, then 0 minus of minus 1 to 1 c, then this is equals to 1 minus 2 plus c, so c is equals to 1, therefore let it be equation number 1. Substituting a, b, c values in equation 1. So we can say mass is directly proportional to a value is minus 1, f value is, b value is plus 1, c value is, very good, t to the power of c value is 1. So this is how we can write dimensionally m value as v to the power of minus 1, f to the power of 1, t to the power of 1. And I am giving your homework as homework b bit in the question, I am giving you this as your homework. And the next model of the question in the same concept is, see here, suppose if alpha is equals to f by v square sin beta t. Here v is equals to velocity, f is equals to force, t is equals to time. Find the dimensions of alpha and beta, and note here sine, cos, tan, cot, cosecant, secant. These are having dimensional formula as m, l, 0. Similarly logarithm also m0, l0, t0. These are having like this. So here sin bt, which is equals to m0, l0, t0. Therefore we can write here bt is equals to m0, l0, t0. Then b is equals to t minus 1. Dimensional formula for beta is equals to m0, l0, t minus 1. This is the dimensional formula for beta. Now let us see. Next they are asking us to find the dimensional formula for alpha also. Now finding dimensional formula for alpha, that is alpha is equals to f by v square m0, l0, t0, since sine having dimensional formula as m0, l0, t0. So alpha is equals to f by v square, that is alpha is m, l, t minus 2, that is force dimensional formula. Now v is the velocity, its dimensional formula is lt minus 1, 2. Alpha is equals to m, l, t minus 2, l2, t minus 2. So alpha is equals to m1, l minus 2, l minus 1. So these two will get cancelled. This is the dimensional formula for alpha. Clear? Chalo. Similarly, one more question for your clarity. Alpha is equals to fv square by beta square log e 2 pi beta by v square, where f is the force, v is the velocity. Find dimension of alpha and beta. And see here, log is itself having no dimensions, so which is equals to m0, l0, t0, and this is 2 pi b by v square is equals to m0, l0, t0. Then here 2 pi is the constant, we can omit that. So beta is equals to v square and v is the velocity. So beta is equals to lt minus 1 square. So dimensional formula of beta is dimensional formula for beta is m0, l2, t minus 2. Similarly, we need to find dimensional formula for alpha. Similarly, dimensional formula for alpha, is equals to fv square beta square log e 2 pi beta by v square. So here alpha is equals to fv square b square and this is equals to m0, l0, t0, since log has dimensional formula as m0, l0, t0, right? Then alpha is equals to fv square by beta square. Then alpha is mlt minus 2, lt minus 1, and beta value we found as m0, l2, t minus 2. Therefore this is equals to This is of course 0 means we can omit that for clarity. M, L, L, L get cancelled. T minus 2 will get cancelled. And answer becomes M, L0, T minus 2. This is the dimensional formula for alpha. And this is what is the complete dimensional analysis I gave you in one class. And I will definitely send you practice problems over this concept through our Telegram channel. Physics with Jagan sir. I will send you practice problems over the dimension analysis in this channel, and stay tuned with my classes and stay tuned with this channel. You will get the sufficient material for your examination. And if you have any doubts in this topic, you can raise them in our message box in YouTube. Have a great day. Take care. Bye. Thank you.